Hey everyone, welcome to part 2 of our equivalent fractions video. Now before we start, there are a few things I want to cover to make sure you can get the most out of this video. Number 1, make sure you check out the glossary in the description box below. Just scroll down that way. These are the academic terms I will be using, so please make sure you up your vocab game. Second thing is, whenever you see this counter over here, that means I'm going to be asking you a question. I'm going to want you to pause this video and take the time to come up with an answer. Once the counter gets to 0, I will then go over the problem. Now let's get good. So last time I was telling you about equivalent fractions being fractions that are the same, but they have a different name. Meaning we can always have a certain fraction of something no matter how many parts we cut the whole into. Notice how half of the rectangle is highlighted, and as we cut the rectangle into different numbers of equal parts, the number of parts increases, but the highlighted portion remains the same. That means I can cut that rectangle into 1,000 pieces or 1,000,000 pieces, and I would still be able to identify what 1/2 of that rectangle is. Keep in mind that equivalent fractions are not just restricted to halves. We can have equivalent fractions for 1/3, 2/5, 7/8. Every fraction out there has multiple equivalent fractions to them. So I left you hanging with the challenging question last episode. Your challenging question was to figure out what was the pattern between these equivalent fractions. And the pattern was both the numerator and the denominator were being multiplied by 2. All right, hold on to that way of thinking because I want you to figure out the pattern for this next set of equivalent fractions. 1/3 is equivalent to 4/12, which is equivalent to 16/48. Oh look, there's the counter. So you know what to do. Pause the video, take your time to figure out what the pattern is between these equivalent fractions, and then we will go over the answer once that counter hits 0. The pattern is both the numerators and the denominators were being multiplied by 4. All right, let's do one more. What is the pattern for these equivalent fractions? The pattern is both the numerators and the denominators are being multiplied by 6. I hope you've noticed that when we calculate equivalent fractions, we are multiplying a number to both the numerator and the denominator. What that multiplier is does not matter. It can be any number. What matters is that the same number is being multiplied to both the numerator and the denominator. What matters is that the same number is being multiplied to both the numerator and the denominator. Now, I know what you're thinking. You're thinking, what am I going to use this knowledge for? Well, a lot, really. If you ever want to share things with your friends and family, or if you want to gather items to create a party or a gigantic project, equivalent fractions will make your lives easier. And that's the point of learning all of these mathematical concepts. Nobody's ever going to come to you and be like, hey man, what's the equivalent fraction for 3/4? No one's going to do that. What's going to happen is you're going to find yourself in a situation where you can possibly use this formula to make your life easier. If you can recognize the situation that you can use this formula for, well, you will save yourself a lot of time and mental strain. So let's look at one of those situations where we would be using equivalent fractions. Let's say you were promised 2/5 of a bag of stuff. Stuff, in this case, can be anything you want. They could be candy, $100 bills, diamonds, pigs wearing teacup hats, whatever you want. You decide. If the bag has 100 items total, how many items should go to you as promised? Where do we start first? Well, let's focus on what the question is asking. So we are dealing with a whole bag of stuff, and some of those items from the bag are going to be going to you. So we have number of parts that make up a whole and parts that we're focusing on. That sounds like a fraction. What information can we plug in? Do we know the amount of parts we are focusing on? No, because those are the parts that are going to be going to you. We're trying to solve that. So I am going to put an empty box here. Now, let's look at the denominator. Do we have a number that equals the whole? Yeah, the question told us that 100 items makes a full bag. So the whole bag consists of 100 items. Since we also know 2/5 of that bag is going to you, We can write this as an equation. The unknown amount of stuff that is going to you from this full bag of stuff is going to be the same as 2/5. I'm going to flip this equation around because it's easier for me to read it this way. Now remember, if you have numbers that equal each other, it doesn't matter which number is on which side because they equal each other. So this is our formula now. Using what we know about calculating equivalent fractions, we can figure out what number goes in that empty box. We know the same number needs to be multiplied to both the numerator and the denominator. So how can we complete this equation? What do you think? So we can do this by figuring out what is being multiplied to our denominators, then take that same number and then multiply it to our numerator. What times 5 gives us 100? 20. So we now take 20 and multiply it to our numerator. 2 times 20 equals 40. So 40 of those items will be going to you. Those were the parts we were focusing on. All right, it's now time for the challenging question. I'm going to give you a problem for you to solve on your own. And if you get it right, let's celebrate together. If you get it wrong, don't sweat it. Just make sure you watch our equivalent fractions question and review video where I will be covering the problem in detail. And remember friends, you can rewind this video to review the lesson to help you solve this problem if you need to. There's the counter. Good luck. You are at a birthday party and there is an ice cream cake cut into 20 pieces. Someone dares you to eat 3/4 of the cake. How many pieces of cake would you have to eat to complete that dare? And the answer is 15 pieces. And there you have it. You now know what equivalent fractions are and how we can use them to make our lives easier. I hope you found this video helpful. I'm Mr. Wayne signing out. Be safe out there, friends.